What is matter? Matter has to have mass and take up space. Those are the two requirements required for something to be considered matter. So matter is pretty much everything. It could be the air, it could be dirt, it could be water. Everything is matter. Matter is surrounding us. Physical properties are properties of a substance that can be measured without changing the chemical nature of the substance. So if we measure it, it's not going to change the substance. It will not be changed. So a few examples of physical properties are color, shape, density, mass, and volume. We can actually further divide these into intensive and extensive properties. So an intensive property is a property that's independent of the amount. So intensive properties are independent of the amount, while extensive properties are dependent on the amount. So we're going to classify some of the properties we have into these two groups. I like to think about it in if we were to measure a small amount and a large amount, would the value be the same? So a few examples of independent properties or intensive properties here are color and density, because if you had two different amounts of a substance, those values would be the same. And a few examples of extensive properties, we have shape, mass, and volume. All of these are going to change depending upon the amount of the substance that you have. So again, intensive and extensive properties are both physical properties. We only look at these when we're looking at a physical property. Chemical properties are properties of a substance that cannot be measured without changing the chemical nature of a substance. So here I've listed a few chemical properties. The best example to think about what makes something a chemical property, I think, is flammability. Because if you have a flammable substance and you try to light it on fire, it's going to burn and it's no longer going to be the same chemical substance. It's going to change the chemical nature of the substance. So because of that, that makes it a chemical property. If you're testing something and it doesn't change the chemical nature, it's going to be a physical property. Physical changes are changes that don't alter the chemical composition of a substance. So some of the physical changes you could have dissolving a substance, phase changes, so melting, boiling, evaporating, all of those sorts of things would be examples of a physical change. Okay, so also changing the shape. If you had a piece of paper and you ripped it into smaller pieces, you'd still have paper. It's just changing the appearance without changing the chemical nature of the substance. So a chemical change is something that does. So think of a chemical change. So if you burn paper, for example, which some of you have done before, you could identify that is a chemical change. So what happens when you burn a paper? So burning and rusting are examples of some chemical changes. The two things that we notice from both of those is that there's a change in color and a change in odor. There's actually 3 other indicators of a chemical change. So energy given off or absorbed, so if the reaction gets hot or cold, or formation of a gas. So this is not boiling. Boiling is a phase change. This is if you add like baking soda and vinegar together and you make a volcano. You have the gas that is formed. So if you're forming a gas from a chemical reaction, that is an indicator of a chemical change. The last one is formation of a precipitate. So a precipitate is a solid that forms in a solution because of a chemical reaction. The way that you can tell that it is formed is that it becomes a solid or the solution becomes cloudy. We're going to do several precipitate reactions throughout the year, but the big thing is that you have a solid that makes the solution cloudy, and then the solid eventually was able to either be filtered out or sink to the bottom. We have solids, liquids, and gases, and just you've seen those little pictures of the little spheres. The big thing with a solid is that they have a definite shape, and volume. So if you had a block of wood, it has that shape, it has that volume. You could change it if you cut it or broke it, but for the it still will retain that same shape and volume. A liquid, on the other hand, only has a definite volume. It has no definite shape. So the liquid will take the shape of your container, while a gas has no definite volume or shape. So that we actually will take a whole unit to talk about gases. Gases have no definite shape or volume. It allows some of the properties of gases that we need for our everyday lives to be able to be successful. So vapor, not the same as a gas. A vapor refers to something in the gaseous phase. Then an alloy is a solid solution composed of two or more elements. We do need to review the phase changes that occur here. I like to think of water, what it does, because water, we've seen all of these phase changes happen before, so it's a good way to visualize it. Forward a little. So the going from a solid to a gas is sublimation. The best example of this is dry ice. Going from a solid form to the gas. And then gas to solid is deposition. Deposition, if you heat a metal up very hot and make it evaporate, you can then deposit it on things. This one's a little bit harder to visualize, but again, it's not as common as the other items. Plasmas we don't really experience on the planet Earth, but they're high temperature, low pressure environments when the electron separates from the nucleus. However, it's very common throughout the universe. The last bit of notes for the day are going to talk about elements, compounds, mixtures, and solutions. So this is just for classification purposes. When you have a certain type of solution or you have a certain thing, you want to classify it into a group, this is what we end up using. So an element is a pure substance that's made up of only one type of atom and cannot be broken down by physical or chemical needs. It can only be broken down by nuclear means, which isn't something that we'll be able to do in our class. Okay. So an element is anything off the periodic table: carbon, gold, lithium, silver, pretty much anything. Compounds are when you have a combination of two or more elements that are different and they're combined chemically. So something like water is an example of a compound. You have oxygen and hydrogen together. Glucose, or C6H12O6. So sodium chloride or salt and then carbon dioxide are also examples of compounds. A mixture is when you have a combination of two or more pure substances. So both compounds and elements are considered pure substances. So a mixture is when you have multiple pure substances together. So you could have carbon and water mixed together, or gold and water, or gold and salt. All of those would be considered mixtures. We actually classify mixtures even more. We classify them as homogeneous, which is when the composition is uniform throughout, so you can't pick out pieces of it. And then also heterogeneous mixtures, that's when it's not uniform, so you can distinguish different parts. So often in a heterogeneous mixture, you'll see things settle out. You'll be able to pick out different things. So both salt water, soda, sugar water, a lot of them are homogeneous. We'd like to refer to them as solutions. This is what we'll be working with a lot, usually with water. Heterogeneous mixtures are mixtures where it's not uniform. So elements can only be broken down by nuclear reactions, as we said. Compounds can be broken down by chemical reactions. This is what we're going to be spending most of our year talking about, chemical reactions of compounds. Mixtures can only be broken, they can be broken down by physical means. So we're going to talk about a few ways we can physically separate things. So if you filter something, you're filtering by particle size. So if you've ever made coffee before, you have filtered something. So what you're doing is you're separating by particle size. So if you have salt, if you have sand and salt mixture and you dissolve it in water, the salt will dissolve but the sand won't, so you could filter the sand out of your solution. So particle size is how we filter. Filtering has been done. Now, there's things you can't filter. So for example, if you tried to filter out, like let's say you added some food coloring to some water and you made your water blue. Well, that food coloring you can't filter out. That's not going to be changing particle size because those are two liquids. The big thing here is that you have to have a particle size that's larger. So like something like sand or coffee grounds that is significantly larger than the other component. The next item here is distillation. So you're distilling something, you're separating by boiling point. When you distill something, what's happening is you heat up the mixture, and the thing that has the lower boiling point is going to evaporate first. It'll travel up this enclosure and then go through the condenser, which results in another liquid. So this is something, if you've ever had distilled water, that's the process they go through. They're trying to remove the minerals from the water. Or there's a lot of other examples of this distillation. Chromatography is a physical separation process based on attraction. So that's the key here. Chromatography is based on attraction. Usually it's a liquid or a solid. For paper chromatography, use paper. These are examples of dyes that were separated. Dyes or ink are common things that you use chromatography for analysis to figure out what are the components. You can actually do this with if you take a brown M&M and put a little bit of water on it on a paper towel. You can actually see all the colors that make up the brown color on the M&Ms, which is a fun little experiment that you can do, because the liquid, what it's allowing to do is it's allowing to separate the dyes based on their attraction to whatever you're working with. So whether it's a paper towel or a piece of paper. You completed this in biology, I think, as